Welcome back to NETGEAR's webinar series. Thank you for joining us today. My name is Rachel and I'll be your host. Today we have Xavi joining us. He is our CBU product line manager for switching. And our topic today is need for speed, 5-speed networking for SMBs. We're going to discover how to deploy 10 gigabit and multi-gigabit solutions for SMBs. And as always, if you have any questions during the presentation, go ahead and write it in the chat or in the Q&A, and we'll get to it either during the presentation or at the very end for a Q&A session. All right, go ahead and take it away, Xavi.
Thanks, Rachel. Thank you, everybody, for joining us in this webinar. So I am Xavi Leisha. I am the CBU PLM for switching in this, at NETGEAR in Advanced and Plus. And today we're going to talk about 5-speed networking. So yeah, it sounds cool. It's kind of like the new car, but this is real. Like that's something that it's changing the way that we are deploying networks right now. As you guys know, normally we are talking about gigabit, 10 gigabit, 100 meg. So we're introducing a new area in networking that's the 5-speed. So this 5-speed is related to the multi-gig. It's the 5 gigabit and 2.5 gig. And today I want to give you guys an update about the current products, the current solutions that we have, and why this is really the next generation of networking. So saying this, we're going to start on doing the presentation. So what we're going to cover today is, first, we're going to cover an introduction about what is the current solutions that we have. We are going to talk about the design, so how we can design the networks in order to be able to achieve the performance that we want. We're going to talk about the multi-gig, so a little bit more information about what is this multi-gig, what is this 5-speed networking. And we also gonna cover the performance and the different products that we already have in this area. So saying that is the first question that we have to ask ourselves when we are talking about any computer system, any network is, what is my bottleneck? So when we deploy networks, you know, guys, sometimes the bottleneck could be the internet access, or could be the Wi-Fi access. And the thing is that that's changing. And now we're going to talk a little bit more about what is this current bottleneck and why, like, now we need to go over this 1 gigabit per second, because this picture just reflects a little bit what is currently happening in our networks today. Also, there is like other changes that we are seeing, like, for example, some ISPs that are offering already speeds over 1 gigabit per second. So that's just making this go beyond 1 gigabit per second even more real, I will say. It's even more important and in our current implementations. So if we look like what is the current bottleneck, we know that in 2000 was the CPU, but that moved from the CPU to the memory, and from the memory to the storage. So the latest one, and it was the storage, and that's the one that I want to highlight. If you guys you just look like what are the different computers, what you can buy today, what's the hard drives that these computers have, most of them, you know that they're gonna have the storage, it's going to be SSD. So when we look at the performance of these storage devices, what we can see is that, yeah, if we look the 10K hard drive, the HDDs, we used to have till 2014. These ones were below 1 gigabit per second. But look, when we moved up into the SSDs, what currently happens is that we are breaking this barrier of 1 gigabit per second. So that's the first time that the slowest component on our computers is our network. And look at that, right? The new generation, the new SSDs, they are able to reach by far, as you can see, the speeds of 1 gigabit per second, and even like some of them even go beyond the 10 gigabits per second. But that's what I really want to highlight. If you guys see right now, if you look like your computers, you're gonna see most of you using SSDs. And remember, like now, any kind of operation that you do in your network, if you have a SSD drive, your bottleneck is your network. So that's what we want to cover the network right now. So if we look at the network, what we know is that 90% of the switch ports that we ship are 1 gigabit per second. So that's what we can see this really bottleneck in our network. Also, this is a technology that was released prior to 2000. So we're talking about a 20-year-old technology. So imagine, like, just to do a comparison with the Wi-Fi, that's kind of comparing like the 11AC that we have right now, already going beyond 1 gigabit to 54 megabit per second, like that it used to be like in 2000 or even lower than that. So in the Ethernet space, we are still using this 20-year-old technology, the gigabit per second, and that's the most common one. However, as you can see, there's something that's changing in this chart. As you can see, the evolution of Ethernet has been from 10 megabit per second to 100, from 100 to 1 gigabit, from 1 gigabit to 10 gig. But as you can see here, there is like two paths right now, 140 gig, and also these new bullets here, it appears like the 2.5, the 5, 25, 50, 200. So as you can see, it's not anymore this 10 factor. We are also bringing and breaking down the speed in more speeds, like the 5 gigabit, the 2.5 gigabit per second speeds on this on the network evolution. And we're gonna see why we really need this 5 gig and 2.5, because they are quite important right now. So even if we look, just to reinforce this message, is that even if we look the current peripherals, what is the USB or the Thunderbolt, what we can see is that USB 3.1, that's the most common one right now, it's already reaching this 10 gigabit per second. And Thunderbolt 3, another like type of connector, it's already reaching 40 gigabit per second. So what we can see is that 1 gigabit per second, it's already like a very old and slow technology. Even that for us, it's the most common implemented technology in the network. We have to realize that with the SSDs and the new peripherals, the speed of 1 gigabit per second is just too slow. So when we look the different components in our computer, what we can see is that we are really getting a bottleneck in our network. All the other buses, all the other peripherals, they go beyond 1 gigabit. Some of them, they go even beyond 10 gigabit per second. And as I said, like the latest one was the hard drive, that we moved the hard drive from this 1 gigabit per second bottleneck. When moving to the SSDs, we are now over 1 gigabit per second. So we really need to move up on our network side. And if we want to take advantage, as you know, like of our computer side, we really need to upgrade our network and go beyond this 1 gigabit per second. So at the end, like the computers are like Ferraris that we are driving in this kind of a small road. So imagine trying to drive like a high powerful car in a very narrow road. So that will not work. So we really need to build networks that are capable of handling all these new fast computers that we are seeing into the market. So let's just cover how we can design these new networks. So how we really can take advantage of these new speeds and how we should design the networks in our space. So the first thing is that we can see normally in the network, we recommend to not go over more than 3 hops. So we have the core, the access, and the access. And if we can do like 2 layers, just one core switch and the access, that will be better. Because what we really need to think about it is that every time that we add another switch, if we are using the normal, the gigabit per second, the gigabit connections, that's currently like the most used network. So the issue is not that we are just using gigabit connection to connect our computers. The biggest issue is that we are using gigabit connections to interconnect our switches. So that's what is really bad, because when we are using gigabit connections to interconnect the switches, it means that we are doing something that's called the oversubscription. This is the ratio that it appears here. So we have access switch, a 24-port gigabit switch. It's quite common. And we have an uplink that's 1 gigabit. So what it means is that 24 computers have to share this 1 gigabit per second connectivity. So at the end, like a real throughput that I'm gonna get if everybody wants to use the uplink at the same time is that the maximum speed that I can get is 41 megabit per second. And if we do like a second layer, if we do like add another switch, what it means is that this computer here, if everybody wants to use the network at the same time, like the worst case, it will be like just 1.7 megabit per second. So as you guys, you can see, this is really bad. That's currently nothing like to be able even like to watch a video. It's not good enough. So that's something that we really need to think about when we are talking about designing networks, so how we can design a network to handle this speed. So the first thing is that, yeah, we shouldn't have more than 2 layers, and we should use, instead of connectivity, instead of using this gigabit, we should move up and use, for example, 10 gigabit. So the approach should be the one of the first tips and advices is going to be to use the start topology. So get like one switch, the main switch as a core, and just access switches. Don't get like switches in cascade. Don't try to get like more of them cascaded, because at the end that will impact the performance of the devices that are connected to the other switches, and also it will add latency. So that's what we want to avoid. So that should be like the first recommendation. Try to the core and the access, so at least you get a better speed for everybody. Just you guys, you can see between these 2 scenarios here, the speed when everybody was talking at the same time was 1.73 megabit per second. Here, the speed when everybody's talking is 41 megabit per second. So we already get a higher speed, but if we want to get higher, what we recommend is to try to get what we call non-subscription rate. So when we are talking about non-subscription rate, a line rate, to design a network without any bottleneck, any possible bottleneck, what we're talking is here, as you guys, you can see, is we are using the access switches, and instead of using gigabit links, we are using these 10 gigabit per second links between the access switches and the core switch. So what we can see is that if we compare here the number, it was 24:1. Now it's 24:40. So 2 things that we have to realize in this scenario. The first one is that now this number, the 41, is bigger than the 24. And the second one is that we are getting, instead of 41 megabit per second, 1.6 gigabit per second. So what it means is that even like everybody, the worst case scenario here, in the worst case scenario, we are able to deliver 1.6 gigabit per second of connectivity to each computer. And we are able to achieve this using these 10 gigabit uplinks. And as we're gonna see later, that's quite relevant, because right now, not only the servers and not only the storage are going to the 10 gigabit or to the multi-gigabit speed. Also, we have computers going to this speed, as we see before. As we saw before, the new bottleneck of any computer, it's going to be our network. So let's talk a little bit more about the multi-gigabit. So why this multi-gigabit is important. So multi-gigabit, it's important because the Cat5e cables, if we look the cabling that we have, most of them are Cat5e. The Cat5e, we can have Cat6, Cat6a. It's the category of the cable. It just means like how good the cable is. So the latest cabling, you guys are gonna find, for example, Cat6 or Cat6a cables, or even Cat7 in some cases. But the all cables are Cat5e, and unfortunately, all of them are limited to 1 gigabit per second till we release the multi-gig. A multi-gig was approved 2016, so that's quite new. It's already like a certified technology. So remember this one, the BZ. So BZ is the NBC, it's the certified technology, the multi-gig technology that allows any interoperability between the different vendors, and now it's a standard for the IEEE. So that's really important because in 2016, this world changed, and it changed in order to be able to get a faster speed, because the cabling it has like a big implication. So this implication is that currently, like if we just look like the 10 gigabit per second, like we can run 10 gigabit according to standard. We need Cat6 to be able to run 10 gigabit. And it only, and the other issue is that the IEEE standard only assures us that we can run 10 gigabit per second in Cat6 cables at 55 meters. If we go beyond these 55 meters, there is no assurance that we are going to be able to run this 10 gigabit per second connectivity. And in Cat5, Cat5e, same thing. Even like 1 meter or 2 meters, the IEEE says that, yeah, you can try, maybe it will work, but it's no assurance. So if you want to run 10 gig minimum, Cat6 or beyond. And that's the issue that, yeah, 75% of the cabling, it's Cat5e. So that's the thing, like that. What we are seeing is that most of the cables are Cat5e, Cat5 or Cat5e. So we know that the cost of replacing these cables, it's around $300 because you need to rewire. You need like, yeah, imagine like your office right now. If you need to rewire all your office, that's something that you just do it once, you know, like in a while. And normally, if you don't rewire your network cable. So in order to take advantage of this, the IEEE, the N-base-T, it allows us to run 2.5 gig and 5 gig. So now we have another speed. So that's why we call this 5-speed networking. So we have 100 meg, one speed, 1 gigabit, the second speed, 2.5 gigabit, the third speed, 5 gig as a fourth speed, and the 10 gigabit as the 5th speed. So that's why we have these 5 speeds on our network interfaces. So that's the M-base-T with the 10 gig, 5 gig, 2.5 gig, 1 gig, and 100 meg. And the great news is that we can run 2.5 gig and 5 gig on the Cat5e. So what happens right now is that using the same cabling, the same cables that you have, you don't need to be worried about it. You can just use the same cables and you're going to be able to run not 10 gig, but 5 gig, so 5 times faster. So that's why this M-base-T is really important, and why like the network that you are deploying, it's going to be able to provide you 5 times faster speed than what you used to have. So again, like in the 10 gig, 55 meters, just remember these ones, and that's why we want this Cat5e and the multi-gig technology. And the multi-gig technology goes a little bit beyond. It offers some new features like the automatic downshift. So when we are talking about the speeds that we are using in our network, normally when we have, for example, 10 gig or 1 gig, what happens is that, okay, I have my computer, and I have the switch. So I have, like, for example, a computer that supports 10 gig, and I just plug this 10 gig, this Ethernet cable from my computer to the switch. And when I plug the computer to the switch, at that moment is when the computer and the switch negotiates the speed, and if both of them support 10 gig, they will set it up at 10 gig. And if both of them, they support 1 gig, both of them will be set it up at 1 gig. But that's not always the best case. Sometimes it can happen that there are some network interference, and running it at 10 gig can be worse than running it on 1 gig, because I have to retransmit so many packets. That's something quite common when we are talking about Wi-Fi. You just need to imagine what happened when you are moving far away from the access point. What happens is that the speed that you are getting, it's getting lower and lower and lower, because when you're moving far away from your access point, yeah, you have more interference on it. However, like we just reduce the speed in order to reduce this interference. So here in the MBST, we are doing the same. So we can start with a link at 5 gig, for example, but if it goes bad, if we have interference and we have problems, it will go down to 2.5 gig or to 1 gigabit per second. So that's also why having 2.5 gig, it's important, because in some cases where 5 gig, maybe it's not the best option due to interference or the cabling that we have, it's not like, it's not working properly, it will downshift automatically to 2.5 gig. So that's also something really interesting that we have in this multi-gig technology. And when we are talking about the design, what we can see is that, okay, when we saw the previous picture, we have the core and we have the access switches here. So what we can see is that in this case, I have also 4 uplink cables and 4 uplink cables here. So what we can see is now is 24 to 20. So here there is a little bit of oversubscription. So it's not a line rate one, because this number has to be bigger than this one in order to get like a non-blocking network. So this is we have a little bit of blocking here. However, yeah, you can see how much of the improvement that we did. Like we moved up from the 40 megabit per second to this 833 megabit per second. So it's a great improvement. Now every computer here gonna be, in the worst case scenario, gonna be able to have almost 1 gigabit per second of connectivity. So now what I want to talk to you guys is about the ecosystem that's available right now. So what are the different devices that you can use it in this 2.5 gig and 5 gig? Absolutely. We have some switches there. So we have some switches on the 5 gig and the 2.5 gig. So you guys have some switches here, but we have more devices. So when we look like the different devices that we have the switches, but we also have some of the routers. As I said, like even in US, there are a few companies who are already offering speeds over like beyond 1 gigabit per second over fiber or even over cabling. So the new DOCSIS, it's able to offer speeds over 1 gigabit per second. And there are a few ISPs that are already offering over 1 gigabit per second connectivity. So even like the internet speed is going over 1 gigabit per second. So we have the switches, we have the access points that are already working in this multi-gig. So access points is another clear example where we can see that the gigabit per second is not longer good enough. If we look Wi-Fi speed with the new 11AC and now the 11AX, the speeds are over 1 gigabit per second. So yeah, if we have a Wi-Fi that works over 1 gigabit per second and my network cable to the switch is just like a gigabit connection, yeah, that will not work. Will not be able to run to get the maximum bandwidth that we have over the Wi-Fi. We have also some computers and motherboards that they run over these multi-gig and 10 gigabit per second. So we have now, you guys, you can buy already a motherboard with this multi-gig at CES this year. It was like at least 3 new motherboards that supports this 10 gig and M-base-T built in, and also storage. So we have also NAS storage that supports M-base-T and 10 gigabit per second. And not just that, we also have computers that are shipping with the M-base-T. We also have something that's the dongles, the USB-Cs and the Thunderbolt to the Ethernet dongles. So something that I want to talk is about how we can enable the laptops and computers to use the 10 gig and multi-gig. So we have different options. So for desktops, most of them, they have the PCIe connection or USB-C or Thunderbolt. So for the PCIe connection, you guys, you can use these NIC cards. And the great news is that these NIC cards, they used to cost around $300. Now you guys, you can find on the market a Quantia-based NIC cards for around $100. So the price point of enabling your computers or servers to 10 gig, it's not, they are not that expensive anymore. So you can build right now a 10 gigabit per second network using these NIC cards at any time. The other one is also these USB-Cs and Thunderbolt. So if you have a USB-C or Thunderbolt connection, yeah, what you guys, you can see here is this Thunderbolt connectivity with this Thunderbolt to 10 gig M-base-T connection. So it enables any of your laptops to use it as with 10 gigabit connection, even if you don't have an Ethernet port. But if you have the laptops right now are powerful as the computers, as if you look like you have like a great CPU, good an SSD. So again, like the laptops are quite powerful. So in order to enable them to be able to transfer the files, to be able to work faster, we need we can use this 10 gigabit connection using this Thunderbolt or USB-C connectivity. So you guys, you can like enable even like your laptops or desktops to use this 10 gig or multi-gig connectivity. So just I want to give you guys like an update about the latest devices that are coming with this 10 gigabit, multi-gigabit, that you will be able to find it into the market. So there are like just a few new releases so that you guys, you can see like how this market is growing and expanding. So the first one is this iMac Pro. So Apple announced in last December and is shipping already this iMac Pro. So it's a computer, it's a desktop computer that comes with 10 gigabit and N-base-T, so 5-speed networking. So you can have 10 gig, 5 gig, 2.5 gig, 1 gig and 100, so same as our switches. And yeah, this is already, it's not the server, it's not the storage, it's a desktop computer with 10 gig multi-gig built in, because they already realized that the current speed, that getting a 1 gigabit per second, it's already a bottleneck. So they wanted to unlock the potential of this iMac Pro, and they added this 10 gig multi-gig port on it. The other one is that, yeah, you guys, you can find 10 gigabit base cards, like this is a Gigabyte one, a Quantia-based NIC card for around $100. So that's the great news. It's not like as it used to be in terms of pricing. So now it's the time to go and be able to upgrade your computer and use the 10 gigabits or 5 gigabit or 2.5 gig NIC cards. So that's the current like networks that are shipping like from the last quarter. Like there are also other vendors like HP Z Series and Dell Optiplex that they come with their desktops, high-end desktops, that they are also coming with these 10 gigabit and multi-gigabit options on it. So again, like this is the way that the market is expanding. What is quite important is that we are seeing a movement versus like 10 gigabit on the servers and on the storage, also to the desktops, and that's great for us. In gaming, also, like we have some of the ASRock motherboards with this multi-gig built in. These Thunderbolt devices, as I said, like this is they are really good enables for the laptop. So we can have any laptop that that has already 10 gig a Thunderbolt port. You can have 10 gig on it using these Thunderbolt adapters. The Reina 500 and 600 series, X series. So all of them, we have like already like more than 4 SKUs with 10 gig ports built in. So, and not just one, they have two. So 2 port 10 gig built into our Reinas. So you can have your storage using 10 gig. And we also have these line scan cameras. Right now, that's quite interesting. It's not just the sorry guys, it's not just the devices or the computers. Even the cameras are moving to the 10 gigabit and multi-gig. So same thing here. The gigabit per second is not fast enough to be able to handle all these high resolution cameras. So these ones are coming with built-in multi-gig port, and as I said, like for example, access points like our WAC 740 that has a 2.5 gig port on it. So that's just like part of the ecosystem that I wanted to highlight. So now I just want to show it to you guys, like how fast it is. So in order to be able to do this, what we did is we set up a test lab where we put like a iMac Pro with SSD drive, our latest XS512EM. So this is one of the latest products that we introduced. So it's 12 port. All of them can run this 5-speed, so 10 gig, 5 gig, 2.5 gig, 1 gig. And it has copper and also fiber. So in some cases that we still have some SFP plus connectors. So we can use, like, for example, with our router R9000, we can use a 10 gig SFP plus DAC cable to have this 10 gig connectivity. But what we are gonna do is do some tests between our iMac Pro and our Retina. So just moving files and doing a speedometer. So you guys are gonna see like what's the difference when we force the speed at 1 gigabit or when we force the speed at 5 gig or 10 gigabit per second. So what I really need is just like a computer with this 10 gig 10 gig built-in port, or for example, using one of, as we saw, like the 10 gig NICs or the Thunderbolt adapters, and a Retina with the 10 gig and SSD drive. So now let me just show it to you how it looks, the system. I just created a video to make it easier and faster to show it to you guys. So as I said, like we have a PC with the SSD drive and 5 gigabit bandwidth usage. So here what we did is we forced the speed of our switch at 5 gigabit per second as maximum. And we have here first in our left, we have the 1 gigabit area, and we have here the 5 gigabit speed. So we did the test with the 1 gigabit and the 5 gigabit switch. So we're gonna see how fast it is. So we're just gonna click start the test. As you can see, now we are doing the test, and yeah, have a look on this area. What we're gonna see is that the maximum speed of both in this case is around, as you can see, is around 110 megabyte per second. So just please, as this is storage, you can see that's more related to megabyte per second. So 110, that's, yeah, if you multiply by 8, that's a megabits per second. That's where we are talking about this 900, 950 megabit per second. That's the current limit of the gigabit connectivity. However, when we look at the right now at the 5 gig, at the 10 gig multi-gig switch, what we can see is that, yeah, the write speed, as we are using just one SSD, it's 150. So we are talking about the already like getting around 200, 300, like around this higher percentage of the bandwidth. However, when we took a look into the read speeds, we can see that we can read like 520 megabytes per second, so almost this 5 gigabit per second barrier. So what we can see here is that the limit, it's really on the network side. So if we want to unlock the potential, yeah, we are able to multiply by 5 the speed. And as I said, like if we were having like multiple SSDs in our storage or the latest SSDs, we are gonna be able to see that at 500. So if we look now, we are gonna do the same, but we're gonna change right now the connectivity, and instead of using 5 gig, we're gonna use 10 gig in this case. So we are gonna run the same test. On your left, you have the 1 gigabit per second, and on your right, we have this 10 gigabit per second. So as you can see here, when we have a look into the speed, what I want to highlight is this number here is 1,015, so almost 10 times faster than our current read speeds using 1 gigabit per second. So as easy it looks, it's something that you can test. It's just poor performance. It's proven. It's the network can run like 10 times faster, and the SSD drives are faster than that. We are able to achieve these higher speeds. So just imagine in transferring a 1 gigabyte file, it will take you 10 times less. So anything that you do in your network, like for example, if you have like a AutoCAD or a video that you want to move on your network side, now it's gonna be 10 times faster to do anything in your network. So that's what we want really to highlight here. And it also, it makes some changes in the way that we can, for example, in the way that we can work. No, for example, some of the media creative people and designers, what they are doing right now is that they work locally in their computers, and later on they move the files to another place because their network is not that fast and their storage is not that fast. But right now, getting them into this 10 gig, getting them like being able to use 10 gig, they can start using already like shared storage for them in a high speed, because they're gonna be able to get this 10 gigabit connectivity. So just to wrap it up, I want to have like a quick overview about the products that we already have, that we support this 10 gig and multi-gig connectivity, and later on we are gonna do a Q&A session. So if you have like any question that I saw, there are a few, we are gonna cover it just after the this last section. That's the part of our products. So when we have a look about how many 10 gig, multi-gig, this 5-speed networking, how many of those do we have? So as you can see, we have a complete portfolio. We have 9 switches already on this 10 gig, multi-gig space. So we have different types of management. So we go from unmanaged space. We have, so you just plug and play. These ones, you don't have to, you are not gonna be able to configure it, but you just have like to plug and play, and they will be able to deliver this 5-speed networking to your network. And we have the Plus, we have also Pros, and we have like also fully managed. So we have all different types of management depending what you want to do. So even like basic VLANs, QoS, or advanced features like routing. So we do have like a product in this 5-speed networking that will support that. And we have a multiple combination of ports. So we have 5 ports, all of them like 10 gig, multi-gig, 8 port, all of them 10 gig, multi-gig. We have also 8 port with 2 ports. So these are like the uplinks. So these are quite interesting products because we have 8 ports with 2 ports, 10 gig, multi-gig in Unmatched and Plus. And we also have a Smart Pro switches with the also uplinks with the 10 gig ports and a combination of 5 gig and 2.5 gig with PoE and without PoE to also build the network, this fast network that we want. And we have also like the 10 port, 12 port, and 24 port that I want to cover a little bit more because that's the latest ones that we just introduced at CES this year. So they are brand new, just they got like less than a month into the market. So just let me show it to you guys what we put in this new product. So these are the XS512EM and XS724EM. So XS512EM, as you can see, it's a little bit shorter, so it's a desktop and rack mount, but when you are gonna be able to use it as a desktop, yeah, it's a small form factor. So it's a 13-inch rack size, but it comes with the 19-inch ears, so you can mount it. And it has internal power supply. It comes with our lifetime warranty. It has basic VLAN. It has VLANs like port-based VLAN, the 1Q VLAN. It supports static lock and LACP. We also have loop prevention and loop detection built in. We have QoS. So all the software features that you require are there. And we have these 12 port that all of them, they can run 10 gig, 5 gig, 2.5 gig, and 1 gig, and 100. And these 2 fiber ports, so you also can run some fiber connectivity or DAC cables for devices that they don't have copper on it. And the second one that we introduced is this XS724EM, so 24 port. In a 24 port in a rack mount, that with 2 SFP plus, and again, all these 24 ports can run 10 gig, 5 gig, 2.5 gig, and 1 gig at the same time. And we have this 2-port fiber on it. And here you can see the back size of these switches. So these are just, we are just expanding our product portfolio, adding more and more switches with 10 gig and multi-gig based on it. So in order that you can build the network that you want. And if we look, I just want to also highlight another product that we introduced. This is the GS810EMX. So this is more designed for gamers. It's under our new branding, the Nighthawk Pro Gamer. And it got like a CES award, the 2018 CES award. It comes with 8-port gigabit, but these 2 ports here are 10 gig and M-base-T, so 10 gig and multi-gig ports. And we have the all the features of our Nighthawk switch, so one-click setup, mobile web optimized, but we added 2 new features here. The first one is a network monitor and health status that we call gaming dashboard. So you have in one page, you can see real-time statistics about bandwidth usage, and you also can configure rate limiting and priority per port. And we have the RGB LED controls where you can customize every speed of each LED in the color that you want, and even the power LED. So you can customize everything that you want on that one. So just to wrap it up right now, I just want to say that, yeah, there are 5 reasons that you have to consider to move beyond 1 gigabit right now. So first is the affordability. Pricing just came down, as I said, like the NETGEARs, the 10 gig ports, we're talking about 1/3 of what it used to be. So really affordable, $100 for a NETGEAR, less than $100 per a port, per a switch port. Endpoints, you have more and more products that are coming with this 10 gig, and you have this enables NICs and Thunderbolt to 10 gig and USB-C to 5 gig to be able to get these higher speeds. And you have this, you can use your cables that you have right now, so you don't have to recable or rewire anything. You just need to put the switches there, and it's ready to work. The performance, as we saw, it's proven. It's you just need like the switch and do a quick test. It's not just that we are saying that you can achieve 10 gig. It's real, like it's the same as the gigabit. When we're talking about the gigabit network, we can achieve this 950 throughput megabit per second. In a 10 gig, we can achieve this 9.5 gigabit per second throughput, and this is real throughput. And the 5-speed, so you have more options to get now like this, get the speed that your different devices gonna need. So saying that, I think that Rachel would be like a good time to start our Q&A session.
Definitely. We already have a few questions. Thank you so much for that wonderful presentation. All right, so we have a question from Donald. He's asking, how loud is the fan on the new XS512EM and the XS724EM?
So for that one, what we did is we put active fans. So for what we are doing is that we only turn these ones up when it's required. So they are whisper quiet. That's what we call. So depending on how many like devices you are running on 10 gig, because the 10 gig is the one that draws more power and it requires like a better heating system. But for example, if you're using like a gigabit, for example, it will not make like it's quite silent. And with 10 gig, it will have like a little bit of noise. But again, like with the active fans, in a normal temperature, like in a 25, in 100, like 90 degrees more or less, what we're gonna have is like kind of a quiet fan, so that's you can work with a normal in a normal office, and you will not notice the fan in this case.
Thank you so much. And then we have a second question from Kevin. He's asking if these multi-gig switches support PoE+.
So yeah, when we were covering these ones, so we have two models that supports PoE, and both of them, they support PoE+. So we have these MS510T XPP and the M4200, and both of them, they have 8 ports, and the 8 ports supports PoE+.
And then one more question from Michael. He's asking if there are options for a second PSU.
No, that's something that we don't have right now. Sorry, guys. That's the in the switches that we have. These ones is all of them are single PSU. However, we do have some switches with redundant PSU. That's our M4300s, and they are really good products. It's our fully managed ones, and they are, we also have hot swappable PSUs on that ones, but they don't support right now multi-gig, so they support or gigabit or 10 gigabit per second.
That looks like all our questions from our audience today. Thank you so much for joining us. We will send you guys a follow-up email later today with the slides, and the video should be coming in the next few weeks. Thank you so much for joining us. Thank you, Xavi, for hosting this wonderful presentation. And if you guys have any questions, feel free to email us. We'd be happy to answer. Thank you, and have a wonderful day.
Yeah, thank you so much for your time. Yeah, hope that you like it, and yeah, have a great day.